In this video, we're going to take a look at equations that are reducible to a quadratic form. A lot of times we have an equation that is not quadratic, like this one. It's not a quadratic equation, but it's in a quadratic form. And we can see that in this case if we put it in fractional exponents. And so we have fractional exponents. We see that here we have x to the first and x to the 1/2. This power is twice as big as this one. So that tells us that it's kind of like a quadratic, even though it doesn't look like it. And we can rewrite this as, well, we need something squared. So if we change this to x to the 1/2 squared, it's still equal to x to the first. Okay. And now we have a connection between that first and second term, because this is a times x to the 1/2. I'm going to put in parentheses so we can see it kind of broken up there. And now we have something squared plus 8 times that same thing minus 9. And so we're going to use what we call u substitution. And we can say that u is, we'll say that u is x to the 1/2. Okay. And now we can put, everywhere that there's x to 1/2, we're going to put u. So we have u squared plus 8 times u minus 9 equals 0. Okay. And we can solve this. This is, and so we have u minus 9 times u plus 1 equals 0. Actually, sorry, let's back that up. Let's make that a plus 9 and a minus 1. How about that? There we go. So we have two solutions here. We know that u plus 9 equals 0 or u minus 1 equals 0. So either u is negative 9 or u is 1. Okay? And now what we need to do is we need to resubstitute for our u, because we know that u is x to the 1/2. So now we need to take this guy and plug it in here. And so we end up with x to the 1/2 equals negative 9, which we're going to square this. And we get x equals 81. Over here we get x to the 1/2 equals 1. We're going to square that. And we end up with x equals 1. Now it looks like we got our solutions, but we've got to test them out. Don't forget to test them out, especially when we're dealing with a square root. So we have 81 plus 8 times the square root of 81 minus 9. Is that equal to 0? Well, let's find out. We've got 81 here. And this is 8 times 9, which is 72. Minus 9 equals 0. Uh-oh, this is not looking too good. Well, we got 153 minus 9. No, that does not equal 0. Okay, so we've got to throw out the 81. And the reason is right here we had the square root of x is negative 9. Well, that's not true. The square root of x can never be negative 9 for the principal root. So now, let's check this out. When x is 1, we have 1 plus 8 times the square root of 1 minus 9. Well, that's going to be 1 plus 8 minus 9, which is pretty clearly 0. That checks out. So our final answer is x equals 1, and that's the only answer. Here's another situation with some negative exponents. We notice that this exponent is twice as big as this one, so that tells us it's in quadratic form. So we're going to need to rewrite it. We need something squared minus 5 times that same something minus 12 equals 0. And if we look carefully, we see that that something is m to the negative 1. Okay, and so now it's in quadratic form. We can see that our u value is going to be m to the negative 1. So we can substitute for that u, and we get 2 times u squared minus 5u minus 12 equals 0. And this can be factored. I'll let you work that out. It's going to be 2u and 1u. And then we're going to have a minus 4 and a plus 3. So you can use an AC method. You can also use a quadratic formula here if you want. But this will do for us. So we have two equations now. We know that 2u plus 3 equals 0, or u minus 4 equals 0. So this is 2u equals negative 3, and u is negative 3 halves. We have here u equals 4, and we add 4 to both sides. Now we need to go ahead and resubstitute for our u here. And we have m to the negative 1 equals negative 3 halves. M to the negative 1 equals 4. And m to the negative 1 is just 1 over m equals negative 3 halves. And so we can cross multiply here, and we get negative 3m equals 2 times 1, which is 2. Divide by negative 3, and we got negative 2/3. Here we've got 1 over m, because m to the negative first is 1 over m, equals 4, or 4 over 1. We cross multiply. 4m equals 1 times 1, which is 1, and so m is 1/4. So it looks like we got our answers. We've got to double check this out here. Okay, and let's come over here to check this out. So we've got 2 times negative 2/3 to the negative 2 power minus 5 times negative 2/3 to the negative 1 power minus 12. Well, negative power is going to flip the fraction and square it here, so we're going to have 2 times 9/4. Flip the fraction and no squaring here is going to be negative 3 halves minus 12. And so this guy is going to simplify to 9 halves. This one here is going to be a plus because the negative and the negative. And we'll have 15 halves there. And why don't we write this as 24 halves so we can see it there. And if we notice, we have 9 plus 15, which is 24, positive 24. Oops, sorry, this should be halves. So we have 24 halves. And so anyways, this whole thing comes out to be 0. It works. And if we have 1/4, we can say we have 2 times 1/4 to the negative 2 minus, squeeze this in here, 5. So we got that squeezed in there. So we have a flip and square. This is going to be 2 times 16. The negative 1 is going to flip this. So this is minus 5 times 4 and minus 12. So this comes out to be 32 minus 20 minus 12, which is 0. It checks out. So we have two answers. There they are. They both work. Here's one that has some fractional exponents, and we want to find the x-intercepts, or I guess in this case the t-intercepts. So to find that, what we need to do is set this equal to 0. The x-intercepts happen when y is 0, or in this case when g of t is 0. So it really comes down to the same thing. And now we need to rewrite this in quadratic form, so we need something squared. Well, what we know from fractional exponents, this is t to the 1/3 squared, so that's a 3 in there. And so this can be written as t to the 1/3 to the first power. So there we see it's in quadratic form. We have squared term first degree, and then we have 3 terms here. So that's good. So we can define our u. And we can say u is Let's see. We can say u is t to the 1/3. And now we can say, do our substitution, and 0 equals u squared minus u minus 2, which factors nicely. We have u minus 2 times u plus 1. And so we have two answers. Either u is 2 or u is negative 1. With our substitution now, we're going to put our t to the 3rd back in. We have t to the 1/3 equals 2, or t to the 1/3 equals negative 1. And we can go ahead and square that. And squaring there, or I'm sorry, cube it actually. And when we cube it, we get t equals 8. Cube this side, and we get negative 1. Okay. So we got two answers. Now the question is, do they both work? Well, let's test it out. Let's check. Okay. So if we check this out, we have t, let's go with 8. 8 to the 2/3 minus 8 to the 1/3 minus 2. Well, 8 to the 2/3 is going to be 2 squared, which is 4. 8 to the 1/3 is 2. And so this is going to come out to be 0. That checks out. Then we're going to plug in negative 1. We have negative 1 to the 2/3. We have negative 1 to the 1/3 minus 2. Negative 1 to the 2/3, well, that's going to square and take the cube root. That's going to be positive 1. Negative 1 to the 1/3 is negative 1 minus 2. This is 1 plus 1 minus 2, which is 0. And that checks out. So we have two answers there. We need them both. And last one here, again, we want the x-intercepts. So we're going to set it equal to 0. So don't let that throw you off there. 10 minus the square root of x squared minus 2 times 10 minus the square root of x. We're looking for our u term, and I think it's pretty easy to see in those parentheses. We've got u is just what the parentheses are. So we can pretty clearly in this one see that u is just those parentheses, 10 minus the square root of x. And so we can substitute, and we have 0 equals u squared minus 2u minus 35, which factors again nicely. U minus 7 times, yeah, that's right, u minus 7 and u plus 5 equals 0. So we have u equals 7 or u equals negative 5. Okay. Now we can resubstitute. Put the 10 minus the square root of x back in here. 10 minus the square root of x equals 5. And let's go ahead and subtract 10 from both sides. We've got negative the square root of x equals negative 3. So the square root of x is 3. Square both sides. And we've got x is 9. Here we've got, let's subtract 10 from both sides, and negative square root of x equals negative 5. So square root of x is 5. Square both sides, and x is 25. Now all we got to do is check. So let's check it. And we have, all right, 10 minus the square root of 9 squared minus 2 times 10 minus the square root of 9 minus 35. Well, 10 minus the square root of 9 is just 10 minus 3, which is 7. Okay. And so this is 49 minus 14 minus 35, which is 0. So that checks out. How about 10 minus the square root of 25? squared. Minus 2 times 10 minus the square root of 25 minus 35. Well, 10 minus the square root of 5 is just 5. So this is 2 times 5 minus 35. And so we have 25 minus 10 minus 35. And so we can see that this does not work out. This is going to be 15 minus 35, so this is negative 20. So that does not work. So we have to throw out the 25, and we have one solution, x equals 9. So there you have it. So find the steps once again. Find the u value. What is it that's being squared here and not squared here in our trinomial? Use your u substitution. Solve for u. Resubstitute and solve. Then don't forget to check, because sometimes we get answers that look right, but they're not actually solutions.